Alright, so we're going to talk about arcs now, and your learning target is I can apply the properties of arcs to solve problems. So first let's go over some types of arcs, okay? Actually the first thing we're going to talk about is the central angle, okay? So your first blank is central angle. A central angle is an angle formed by two lines whose vertex is the center of a circle, okay? So essentially it's like any normal angle, okay? So right on your sheet here, this would be the central angle. Central angle. That might be good to write down too, okay? An arc, okay? An arc is part of the circumference of a circle. It's part of the circumference of a circle measured in degrees. And what you'll see is that the measure of an arc is equal to the measure of the central angle. We call them two different things, but it's important to understand angle is formed by two lines, arc is the curved little section. Okay, they're the exact same thing. Okay, so like let's just pretend right now that this is 75 degrees. The central angle is 75 degrees. The arc is also 75 degrees. They're the exact same measure. Central angle is here. Arc is on the outside though. Now, a minor arc is an arc with whose points are in the interior of the central angle. Okay, so minor arcs are that section from B to C. From B to C. Those are called the minor arc. Whereas a major arc is the section whose points are on the exterior of the central angle. Okay, those are greater than 180 degrees. Minor arcs are less than 180 degrees. Major arcs are greater than 180 degrees. Then you have a semicircle. A semicircle is an arc whose points are in the exterior of a central angle. Those are equal to 180 degrees. That's your straight line. It's marked by the diameter of a circle. That gives you the semicircle. All right? So, now that we've got a couple of those things out of the way, I'm going to just go down here real quickly. This is important information. In order to name an arc, just like we would name a line, right? In order to name an arc, we use points along the circumference of the circle. So like these letters here, G, J, E, and H. Those are all on the circumference. A minor arc is named by 2 points, where a major arc is named by 3 separate points. That's very important for you to understand. Major arc has 3 points when labeled. A minor arc has 2 points. So in example 1, we're going to practice naming the arcs made by the given angle. Okay. So this first one, it says that we want to find the major arc for angle SQU. SQU. And remember, we're talking about a major arc. Major arcs are greater than 180 degrees. That means we're looking for this angle. What is the arc formed by that angle? Okay? And so how we write that is a little line over the top of it like this, a little arch, or an arc, right? And the 3 letters we're going to use is S, T, and U. That would be how you would name an arc given an angle, okay? Now this one, we've got angle CQD. It does not say it's a major arc. It's just an angle CQD. Okay, so it's this angle right here. And so because of that, we only have to use 2 letters, C and D. It's arc CD. All right? That's how you name an arc based on if it's major or minor. Remember, major 3, minor 2. Now we have something called the arc addition postulate. Okay, the arc addition postulate says that essentially it says that if you add 2, or if you have 2 different separate arcs, they can combine to be one arc just by adding their degrees. So the measure of arc ABE, so this whole thing, is equal to the arc of AB plus the arc of BE. All right, and so if we were to actually write this out, it says the measure of an arc formed by 2 adjacent arcs is the sum. It's the addition of both of them, the sum of the measures of the 2 arcs. Okay, that's it. That'll help us with example 2. Example 2 wants us to find the arc HD given the arc or central angle indicated, okay? So we're trying to find HD, arc HD. And if I go ahead and I'm going to highlight this real quick. We're talking about HD, that's this arc right here. Remember, it has 2 points or 2 letters here. That means we're talking about a minor arc. So we're trying to find what this is equal to. Now, you have to use certain pieces of information that we've already learned from this year to be able to figure out what this is. These 2 little lines here mean that these angles are congruent, okay? Those 2 angles combined, they are congruent. Now, here's what we do know is that these lines through here are vertical angles. That means the angle right here is going to be the same of this whole angle over here. And we know that both of these are x plus 62, which means then that 2 times x plus 62, okay, that's these 2 angles combined, is going to be equal to, because of vertical angles, x plus 120. Okay, now all we have to do is just our algebra, just solve for x now. So we're going to first going to distribute the 2 into the parentheses. We'll get 2x plus 124 is equal to x plus 120. I'm going to go ahead and subtract x from both sides. We'll get x plus 124 is equal to 120. And then finally subtract 124 from both sides. And we end up getting x is equal to negative 4. That's the value of x. That's not answering our problem. That's just the value of x. Now that we know what x is, though, we can figure out what the measure of arc HD is by plugging in the negative 4 in for x. Remember, x can be negative. Our angle cannot be negative. So let's go ahead and plug negative 4 back into our equation, x plus 120. And that will give us the arc that we're looking for, arc HD, is equal to negative 4 plus 120, and that's pretty easy. That's just 116 degrees. All right, one last example here. We want to find the measure of arc IM. Okay, so a good idea would be to mark which arc we're talking about, or which section we're talking about. That's that section right there. We're trying to find arc IM, which is our indicated arc right here, okay? Now, if you look at all of the pieces of information here, there's no vertical angles, there's no diameter, so we don't know a certain section is 180 degrees. We don't have a right angle formed, so we don't know if one is a certain 90 degrees. We don't really know much about this problem, except that we do know that all of these angles combined are going to add up to be 360 degrees. So let's go ahead and do that, and we can actually solve for x that way. So we're going to start right here. We've got 85 degrees plus 30x degrees plus 23x, that's the one we're trying to find, plus 9x minus 3 plus 30. And all that's supposed to equal 360 degrees. Now this looks like a mess, but why don't we go ahead and go back? Let's reorder it so that all of our variable terms are on the left side and all of our constants are on the right side. We're just going to reorder that then. We've got 30x, cross that out because I've got that one, plus 23x, plus 9x. That takes care of all of our variables. Now we can add in 85, minus 3, okay? So this should be minus 3 plus 30. And all of that's going to equal 360 degrees. Now we can combine our like terms, right? 30x plus 23x plus 9x. All three of those add up to be 62x. Plus 85 plus 30 minus that extra 3. All those are going to add up to be 112. And we'll set it equal to 360. Now it's just simple algebra. We're just going to subtract 112 from both sides. We get 62x is equal to 248. Divide by 62 on both sides. And we get x is equal to 4. Okay, now that we know what x is equal to 4, we can actually figure out what arc IM is going to be. Remember, arc IM is just equal to 23x, but we know x is just equal to 4, and so we just have to multiply 23 times 4, and we end up getting 92 degrees. Okay, our whole goal of this whole thing was to be able to apply the properties of arcs. You know, those the minor arcs, major arcs, and semicircles. All of those properties, the addition postulate, in order to solve problems involving arcs. Hope you enjoyed.